name is Adam Mock. I'm an assistant professor at Central Michigan University in the School of Engineering and Technology, and I'm an electrical engineering professor. My research deals broadly with photonics. Photonics is the engineering of light. It's kind of like electronics, except replace the electron with photon. So we're engineering with light, building devices. My research personally deals with three sort of target application areas: optical data communication, optical sensing, and solar energy. So broadly speaking, photonics, in particular within the realm of photonics, we're looking at engineering devices at the wavelength scale, the wavelength of light. So we're talking about devices that could fit on a human hair at the width of it. And these devices, again, target areas are data communication, optical sensing, solar energy. All those applications have aspects to them where you can make these very small devices to control light in some way. So with data communication, we're talking about controlling light to convey information or to process information. With optical sensing, we're creating these devices that you can put them into an environment and it can determine whether there is a certain chemical in the air or a certain chemical in the water just because of the way the light passes through it. And with solar energy, it's a little more obvious. We're collecting light. But the idea there is that when the light hits the solar energy collector, or the solar cell, it traps the light, it keeps the light in the device, as opposed to reflecting it or letting it pass through. Trying to trap all the light we can, 100% of the light, and then convert as much of that into electricity as we can. So those are the challenges that we're dealing with.
My name's Aaron Yoon. I'm a computer engineering undergraduate student at Central Michigan. We're trying to set up an experiment to test 2 photon polymerization using SU8 substrate. And right now we're making a two-dimensional stage setup using scrapped DVD drives, so we can make two-dimensional patterns in the SU8 using a laser diode.
So this is a nice experiment. So here what we've got is the light source coming in, we go through the sample, and we measure how much power comes out.
My name is Sheldon Hewlett. I am a grad student here at Central Michigan University. I'm in the Science of Advanced Materials program, I'm a PhD student. I work with Adam Mock, and I guess you could say I do sort of the experimental side of his computation. We take a look at a lot of photonic phenomena. This is the actual detector that we're using. So light starts here, it passes through this aperture, gets sort of collimated by this lens, and then passes through another aperture to kind of narrow the beam a little bit, and then it reflects upward into the sample this way, into the detector. And then we use that's connected to this oscilloscope and get to measure everything we need to measure.
The optical data communication, that's what I did a lot of my graduate work on, my PhD thesis. I actually was using high performance computing resources a lot actually during my PhD work at USC in California. And then when I came to Central Michigan University, I was hoping to carry that over. I know CMU actually doesn't really have that, it doesn't really have a dedicated cluster for that kind of work. So I was very fortunate that was actually when Central Michigan University developed the agreement with Michigan State University to sort of share the resources. Yeah, it's been great. It's very easy to log in. It's as if the resource were next door. One of the things that make sort of research that's research enabling is the infrastructure, and CMU is not quite as big as some of the other places, so it's critical for us to have access to those things. So when we write proposals, it's critical that we sort of indicate that we have very intimate access to these excellent resources from a proposal standpoint, but also just from a publication, kind of day-to-day work. I'm able to log in at any time, do work and submit jobs. And also the staff has been very good. I guess I'm pretty good at doing that stuff, but when I do have a problem, I can usually get a response the same day. I'll a question, let's fix the same day.